Hello, my name is Kajaste, and this project is about using graph theory for learning and predicting flight routes. So the primary objective of this project is to predict future flight routes that could be profitable by identifying potential edges within the complex network of existing flight paths. This is achieved by using graph representational learning techniques to unveil latent connections and predict high demand routes. So the project utilizes the Open Flights dataset, which includes comprehensive data on global airports and routes. And just a summary, it contains around 67,000 flight routes between approximately 3,300 airports and 550 airlines or so. So for graph construction and feature extraction, the first step was handling missing values, standardize text fields and replace missing identifiers with a constant value. Next step was one-hot encoding, which is very common. It's applied to categorical variables such as airline codes, equipment types, airport identifiers to transform them into a binary matrix that's more suitable for computation. And thirdly, graph metrics were calculated. So this step utilized the NetworkX library to compute critical graph-based features like node degree, page rank, which capture the connectivity and significance for each airport or each node within the overall structure. A directed graph was constructed to model the intricate network of the global air transportation system, with nodes representing airports and edges denoting the established flight routes. Each row in the training data represents an airport's feature vector. Each feature vector is a combination of graph features such as in or out degree, page rank, and etc., and also categorical data such as the airline code and the aircraft. All this training data is then fed into a predictive model. So logistic regression is used as a benchmark over here. It's very suitable for binary classification. Random forest classifier was trained with 100 decision trees, and this model improves prediction stability and accuracy by averaging multiple decision trees. Thirdly, support vector machines were used. They were employed to find the optimal hyperplane that maximizes the margin between different classes. And finally, k nearest neighbors was utilized to classify data points based on the proximity to other labeled data points. So the validation strategy plays a very important role here. The overall requirement in this project is to minimize the cost of false positives. Missing a true positive or having a false negative is bearable for such a situation because deploying a flight on a route that is not profitable can be a huge loss-making deal for the company. Therefore, rather than recall, there's an emphasis on precision. The model over here, the models that were used in this project were focused on precision over recall to minimize false positives. Precision ensures that predicted new routes are highly likely to be profitable, and therefore an F0.5 score was used to place 2 times more emphasis on precision rather than recall. This reflects the importance of accurately predicting profitable routes over capturing all possible new routes. And these are the results. All models achieved a decent score, but Random Forest topped that list with the F0.5 score of 9.963. Looking at the confusion matrix for the random forest classifier more closely, it has a high precision for both the classes. On the right side, you'll see the ROC curve, which again shows the random forest with a very high AUC or area under curve of 0.99 compared to the other models. So in conclusion, this project demonstrated the viability of using graph representation learning for predicting new routes. The method combined explicit feature engineering with theoretical metrics to create a robust feature set, the feature vector. Among the models tested, the random forest classifier emerged as the most effective one, achieving the highest accuracy and the F0.5 score. So future work would probably explore more sophisticated encoding techniques and additional features to enhance the prediction accuracy. Implementing these predictive models in real-world scenario could provide valuable insight and drive strategic planning in the industry. Great, thank you.